So hello, let us look at the third section together. So here I'll find a single vector which is equal to. So then once again what we want to do is connect the point. So P to R and R to Q, then this is equal to P to Q vector. How about here? P to S, and then we are looking at S to Q. So but in this case, S to Q and then Q to S. So as you can see, each letter connects. Then this will be equal to P to R, vector P to R. That's what we end up getting. So first question was rather simple. Let's move on to the second question here. So we have three vectors here. First, find m minus n plus p. So that means this is the same thing as 6 minus 2, and then p is as it is, which is minus 1. So we get 3 for the first one. Negative 3 minus 3 becomes negative 6. But plus 3 becomes simply negative 3. Lastly, 1 minus negative 4. That means we end up getting 5, and then plus 6 becomes 11. So that becomes our first vector. How about the second one? Second, 2 times of n, that means 4, 6, negative 8, minus 3 times p, basically, or I can just do addition and then multiply negative 3 in all of them. So we end up getting 3, minus 9, and minus 18. Then we end up getting 7, negative 3, and then negative 26 becomes our final answer. Lastly, what we want to do is we want to add m and p. So when we add up these two, we end up getting 5, 0, and then 7. But we want to find out the magnitude of that it becomes square root of 5 squared plus 0 squared plus 7 squared, which becomes 25 plus 49. 25 plus 49, that's basically what we end up getting. So we get square root of 74. All right, let's move on to the next question, number 4. We have these 2 points. Find the positive vector of Q relative to P, that means from P. So then A, we are looking for P to Q. That's essentially what we're looking for. Is 2 to negative 1, then we have to subtract 3. Negative 5 to 7, that means adding 12. 6 to 9, that means adding 3. So that becomes our first answer. B, I want you to find the distance. Distance from P to Q is same thing as the magnitude of vector PQ. Then we end up getting square root of negative 3 squared plus 12 squared plus 3 squared. Then here we get, that's 9 plus 144 plus 9. Then we get, this is 18. So 144 plus 18, that's essentially what we end up getting. So we get 2 and then 6, 162 is that's basically what we end up getting. Now, I can simplify this one because what 162 is 9 times 8. I mean not 9 times 8. 9 times, oops. 9 times 9 times 2. So we end up getting 9 square root of 2 becomes the distance. And then they want you to figure out the distance from P to x-axis. So P to the x-axis, that means what? P is this particular point. What is the, if you're curious about the x-axis, what is x-axis? That's essentially y and z is equal to 0. That's what x-axis is equal to. That means this x value doesn't count for anything. And we're simply looking for the distance is measured from -5 to 0 because of y value for x-axis is equal to 0, and then z value for x-axis is equal to 0 as well. So we end up getting part C is simply square root of -5 squared plus 6 squared. That's basically what we end up getting. So we get 25 plus 36. So we get square root of 61. That becomes our answer. Number 6. So they want us to find x if p plus p minus 3 times of x equal to 0. Then we realize that in this case, -3, 1, 2, minus 3 times, let me call that as x of 1, x of 2, x of 3 has to be equal to 0. Of course, I understand we can, one thing that which we can do is simply we can divide each component by -3, but this will be the equation which we can write to find that value. Then we end up getting so -3 minus 3 x of 1 is equal to 0. Then we get to realize that x of 1 is equal to -1. Now, second one is 1 minus 3x of 2 is equal to 0. That means x of 2 is equal to 1/3. Likewise, x of 3 would have been equal to 2/3. So in this case, first case, a value of x, or the vector x is -1, 1/3, and 2/3. That becomes our answer. How about part B? 2q. So 2 times of that, I'm just going to multiply that right away. So we get 4, -8, and then 2. So 2q minus x. So we get x of 1, x of 2, x of 3 is equal to r, which is 3, 2, 0. Then 4 minus what equals 3? Oh, that has to be equal to 1. -8 minus what equals -2? Oh, it becomes actually -10. 2 minus what equals 0? So it's going to be 2. So for part B, we can easily get x should be equal to this vector. All right, let's look at number 8. Find t if these are perpendicular. So once again, perpendicular means dot product has to be equal to 0. So we get -4t. Multiplying those two. And when I multiply these two, I get plus t squared plus 3t plus 2. When I multiply those two, lastly, minus 3t has to be equal to 0. Then 3t's cancel out. So what we end up getting is t squared minus 4t plus 2 has to be equal to 0. Then, of course, I can solve this one by quadratic formula or completing the square. Let me just add 2 to complete the square. T squared minus 4t plus 4 equals 2. Then I get t minus 2 squared is equal to 2, where t minus 2 has to be equal to plus or minus square root of 2, where t then is equal to 2 plus or minus square root of 2. We have two values for t. All right, let's look at number 10. Find k if these are unit vectors. So that means for a, I can say square root of 5/13 square plus k square is equal to 1. I know that I can solve it this way, but you can see that this is quite interesting because this is coming from 5, 12, 13 triangle. But you will see when I find the value of k here. Then in this case, this becomes 25/169 plus k square is equal to 1. Then we get to realize that k square is equal to 144 over 169. Hence, k is in fact equal to plus or minus 12 over 13. So we have two values of k for the first one. Now, how about the second one? For part B, k, so that means square root of k squared plus k squared plus k squared has to be equal to 1. And we can see that 3k squared has to be equal to 1. That means k squared has to be equal to 1/3. Then of course we know that then k has to be equal to plus or minus 1 over square root of 3. That means plus or minus radical 3 over 3. That becomes our final answer. All right. Let's look at number 12. And then we have P, Q, and R. And they want us to verify that this is true. All we have to do is actually, calculate the left section and then calculate the right section and then saying that they're equal to each other. So what is, first of all, Q minus R? Q minus R here is -2 minus 1 becomes -3. 5 minus -3 becomes 8. And then I'm going to dot that with P, which is 3, -2. So when I do that, my left side becomes 3 times -3, which is -9. -2 times 8 becomes -16. Hence, we get -25 on my left side. How about on my right side? P dot Q is 3 times -2 is -6. -2 times 5 is -10. Minus. I'm going to put down the parentheses so that I don't forget. P dot R, so 3 times 3 becomes 3. -2 times -3 becomes plus 6. Then what do I get? This becomes -16, and then this becomes -9, which ends up being -25. So we verify that it's equal to each other. They are equal to each other. All right, let's look at number 14. So here, vector P and then vector Q are given in this manner. So first they want us to do dot. That means I'm just going to multiply 2 times -1, so which is -2. -1 times -4, which is plus 4. And 4 times 2 becomes 8. So we end up getting 10. P dot Q is 10. They want us to find the angle between them, so we know that cosine of the angle between them is P dot Q over magnitude of P times magnitude of Q. So then here, what do we end up getting? P dot Q, we already have done it as 10. The magnitude of P is what? 2, -1, 4. All of them has to be squared. Then that gets you 4. That gets you 1, and that gets you 16. So we get square root of 21. And then, how about here? 1, 16, and then 4. Once again, square root of 21. So we get theta is equal to arc cosine, second cosine on your calculator, 10 over 21, because radical 21 times radical 21 is 21. So once you get this value, then you should be able to get your final answer. All right, that's it. I'll see you later.